Hello and welcome back. Today we will continue the concept of initializing weights to fix the issue of vanishing and exploding gradient. As we explain, the method which was suggested by Goulart and he was changing the initial values for weights instead of considering weights which come from standard normal distribution, means mean zero and variance one. We can consider weights which come from one of these two distribution. One of them was normal distribution with mean zero and variance, which can be found by 1 over fan of average. And as we explained, fan of average is fan in plus fan out divided by 2. And let me show you one example about fan in and fan out to understand this better. Then if we have this neural network here, as you can see, we have a neural network with two hidden layers in input and output layer, and these are back propagation process, forward propagate and back propagate. And we have loss score, and the loss score comes from the loss function. And when we want to come back to this network, you have to find the derivative of loss function. When we want to find fan in and fan out, for example, for this layer, what we will do, we will consider the number of neurons that we are inputting and number of neurons that we are outputting. For example, for this hidden layer, the number of networks that we are inputting is 2. The number of neurons that we are outputting is 1, 2, 3, 4. Then here fan in is 1 and fan out is 4. Then fan in and fan out that we have in he formula is very easy, and it can be found from every network. And as we explain, when we want to find the fan of average, you just need to add fan in by fan out and divide by 2. Then if you consider this sigma, this variance, and if you choose your initial weights from this normal distribution, he and Goulart showed in their paper that you can fix the issue of vanishing and exploding problem better. Or you can choose your initial values of weights from normal distribution between negative R and R when R is found from this formula. We have, as we explained in the paper, they consider sigmoid function. In the field, we have other suggestions for dealing with the vanishing and exploding gradient issue, and some very giant names suggested these issues. One of them, for example, which is called Goulart initialization. If you have no activation function, if you have tanh activation function, if you have logistic, or if you have softmax, if you choose your initial value from the normal distribution with mean 0 and variance 1 over fan of average, you can fix the issue of vanishing and exploding gradient. He also suggested for ReLU as the activation function when you have the initial values from normal distribution, which comes from 2 over fan of in. And Lee Kahn, another famous name, suggested that if you have CeLU as the activation function, and if you consider the normal distribution from the variance 1 over fan in again, the issue of vanishing and exploding problem can be fixed. By default, Keras uses Goulart initialization with a uniform distribution. It means that if you do not assign any initialization for your weight, Keras by default consider Gollard initialization, means this initialization with a uniform distribution, not with normal distribution. As we explained in the previous slide, when we say the uniform distribution means that this distribution is considered. It means that the initial values are considered from this distribution. But you can change these to he initialization by setting kernel initializer he uniform or kernel initializer equal to he normal when we want to use he normal or when we want to use he uniform. Then these initial values can be changed through the process of training by using these lines of code, kernel initializer. In another video, when we train one model, I will come back to this kernel initializer and I will explain more about this kernel initializer. Okay, another technique that we want to talk about is batch normalization. It is true that by using he initializing along with relu or other activations that we explain in another slide, we can reduce significantly the vanishing exploding gradient problem at the beginning of training. But it does not guarantee that they will also fix the issue of vanishing, exploding gradient during the training. It means that because, as we explained before, when you use the backpropagation, you want to use backpropagation several times. That's the reason that we assign the number of epoch, because number of epoch tells us how many times the backpropagation process should be done. Then it is possible that through the process of training, again, the issue of vanishing, exploding problem come back. So to fix this issue, in 2015, in a paper, Sergei Lov and Christian Sejidi propose a technique which is called batch normalization. Mostly batch normalization is abbreviated by BN to address the vanishing, exploding gradient problem. Please remember that what Joshua Benjo and Gollard found out. They found out that the issue of this exploding and vanishing gradient happens because it is possible that the volumes of your input through the process of training gets bigger and bigger. Then batch normalization can be used to fix this issue. How? The technique consists of adding an operation in the model just before or after the activation function of each hidden layer, for using the zero centering and normalizing each input. It means that when you batch normalization is one layer which will be added after each hidden layer to normalize the output of that hidden layer. Then by doing this, when we want to normalizing, we need to scaling and shifting the results. Therefore, we need to use two new parameters or vectors per layer, one for scaling and the other for shifting. In other words, this operation lets the model learn the optimal scale and mean of each of the layer inputs. If we want to see this better, then we can use, for example, this example. Then here, as you can see, you have one neural network. The neural network that you have here consists of some hidden layers and input and output layer. As you can see, after each hidden layer, we are adding another layer, which is called the normalization, which is batch normalization. Something that we do here, we are normalizing the output. It means that here, these neurons are input of this layer. You send this input to this hidden layer, and you get some output. The outputs will be sent to this step to get normalized. Then we continue the same process. It means that for every hidden layer, we have one step for normalizing. These concepts, which is very helpful concepts to fix the issue of to fix the issue of vanishing and exploding gradient is called batch normalization. I want to explain a little bit about scaling and shifting in order to see that how we can zero center and normalize the input. The algorithm needs to estimate each input's mean and standard deviation. It does so by evaluating the mean and standard deviation of each input over the current mini batch as follows. It means that when you consider some mini batch, then you will evaluate the estimation for mean by adding all values and dividing by the number of points that you are considering. And if you want to find the estimation for variance, you can use this formula. These are two very famous formulas that we have for normalizing, and these formulas come from statistics. Then, as you can see, something that we do in batch normalization is normalizing each output. And by normalizing each output, we can control the variance of output. Because as we explained before, the issue of exploding and vanishing gradient comes from fact that every time that you send one input to the hidden layer, the variance of input of that hidden layer is smaller than the variance of the output of that hidden layer. And when you have many hidden layers, this variance through the process of learning in the networks gets bigger and bigger. By using the batch normalization, since you are normalizing each output, you are controlling this variance. So batch normalization technique considerably improve all the deep neural networks they experience, with leading to a huge improvement in the ImageNet classification task. We do not talk about ImageNet classification task. This is mostly one task which is more used in deep learning. But if you take any course in deep learning, you will see about this. But the issue of exploding and vanishing gradient is very tricky issue for big network like ImageNet network. Then for something like this, then using batch normalization can improve the network very drastically. Batch normalization does, however, add some complexity to the model. This is actually the downside of the batch normalization, although it can remove the needs for normalizing the input data as we discussed earlier. So then here, as you can see, this batch normalization can be used to fix the issue of exploding gradient, but by using this technique, you are adding more complexity to your model. Okay, I think it is a good time to stop. We will continue